One of the most significant aspects of the modern world is the growth of the human population. So if each of these lines represents 1 billion people, then global population was well under 1 billion people for almost all of human history. It is thought that the human species, Homo sapiens, is somewhere between 200 and 300,000 years old. And at the year 1 BCE, the population was estimated to be 250 billion, 250 million people. It is thought to have reached 500 million, 500 million people in the year 1500. Note that this is double what it was 1,500 years before. So it had taken the global population 1,500 years to double. It is thought that the human population reached 1 billion people in the early 1800s, around 1820s or so. So note that it took 300 years from the 1500s to the 1800s to double again. So the previous doubling was 1,500 years, and this doubling was 300 years. The human population doubled again to 2 billion people in the 1920s. So now it took 100 years to double again. And so from 2 billion in the 1920s, it gets to 4 billion by the 1970s. So it doubled in only about 50 years. And currently we are approaching 8 billion. And so since the 1970s, about 50 years, the population has doubled again. In 2011, the population had 7 billion people in it. This is simply an unsustainable amount of growth. There was an animation at the Museum of Natural History in New York that I decided to try to simulate. That animation did a far better job. But if each of these dots represents 1 million people, one could see that for a long period of time, the human growth rate was rather slow. But then once we start to approach, the 1800s when there were 1 billion people, or the 1900s where there, 1920s where there are 2 billion, or the 1970s where there are 4 billion, or the current day where there are almost 8 billion people on the planet, the just density of humanity is simply amazing. As I'll mention a little bit later, the mass of all of the people on the planet outweigh all of the wild mammals by about a factor of 10 almost. And so what we are witnessing is unusual for 2 reasons. First, there are more people by far than there have ever been. So this population between 7 and 8 billion, this is not normal for almost all of human history. There was well under 1 billion. And then also this rate of growth, although it is slowing, this is unusual. The idea that 1 billion people could be added, say between the year 1999, when we reached 6 billion, to the year around 2012 or 2013, when we reached 7 billion. And so, it took, 100,000 years to reach 1 billion, but in our lifetimes, the population has added over. This is simply that cannot our planet has a finite base of resources, of wild, how other animals live, reef trees, of petroleum accumulation is without that sense of night. It is growing so quickly that this simply cannot be sustained. Before other environmental problems, as people of the carbon as the coal for electricity, as needs to be transformed to roads and cropland and agriculture. There needs to be more petroleum for cars. There needs to be more fish taken for protein. All of these people need stuff. And so if we are continuing to add new people to the planet at around 80 million per year. Now, if you just think about that, if 80 million people were added between the year 2018 and 2019. And 80 million people were added between 2019 in 2020. Tens of millions of people need space for roads and schools and homes. They need crops, they need food, they need oil, they produce trash, they produce carbon dioxide, and this simply growth. People per year, every 4 years, are more. In the year 1950, there were 2.5 billion people on the planet. But the next year, 37 million people were added, then 42 million, then 45 million, then 48, then 52. Once again, tens of millions of people added each and every year. If you were to go through the 1960s, in the year 1966, when I was born, notice that there are about 3.4 billion people on the planet. That's significant because that's about half what it is today. I'm not that old. Our species is hundreds of thousands of years old. 1966 was not that long ago. But nevertheless, half of the human population has been added since 1966 in my lifetime. All right, that's an insane amount of growth. And so we can see that this, just continued to increase. The population went from being, around 6 billion in the year 1999 and 2000. So as you go from 1999 into 2000, the population reaches 6 billion people. But it's not that long afterwards that the population reaches 7 billion people. So 1 billion people are being added to the planet, every 12, 13 years, 1 billion people on the planet. And compare that to 1950, when there were 2 and on the planet, 60 megatons, 60 million metric tons. All of wild mammals only weigh 7 megatons. So human population outweighs all other wild mammals by almost a factor of 10. And then when you take into account human livestock, they outweigh wild mammals by even more. So when you think of all of those individuals who are brought into the world, they need cropland. They need protein sources such as these cows or fisheries, etc. And so this explosive growth of humanity, is absolutely enormous. Once again, there were 80 million people added to the planet between, say, 2019 and 2020. So each of these figures represents 1 million people. 1 million people require a lot of space in order to live, a lot of food. They create a lot of trash. They produce a lot of carbon dioxide. They require a great deal of energy. And 80 million people new this year. Perhaps 80 million people new next year. That's an incredible amount for a population to grow. I teach in Orange County, New York, and global population grows by an Orange County every 2 days. Then, one could ask, the question, I'm being, a little silly in how generalized this is, but one could ask, all right, well, let's take, I don't know, a month's worth of global growth, this many orange counties. Could New York fit them all? Well, you'd want to say no. But the reality is, these people come every single year as population grows. They have to be fit somewhere. Every 3 months, global growth adds the equivalent of a New York state. Could the United States accommodate, say, 10 years of global growth? Could we fit this many more global or populations of New York State? And the answer is, well, it's silly because we will have to. All right, our population has just increased and increased. These people will need to live somewhere. Their croplands, et cetera, will have to be somewhere. If we are adding 1 billion new people in, say, let's say 14 years. So, once again, getting back to this, could the United States fit this many New Yorks? Well, they're going to have to. or some part of the world is, because these people are coming next year. 80 million people will be added to our population if it's a year. And then next year, that's 3 million, and then 10 another billion, and then 50 previous cases, and 3 million that can't fit those. You don't have to go that is what we're currently experiencing. Now, I know it's tempting to be, well, we're just living on this big planet after all. But with that many of us, the weight of all is almost 10 times the weight of all. It ends up it's actually into the geological, and so India is of Earth to 34 glaciation periods are very seen or the anthropology that you and more under the ocean is empowering there are grasslands for and we are having this incredible impact on the natural world. There's less and less of them that will go. You see the croplands of humans, the cow pasture of being changed by humans as carbon dioxide and ice caps which had not been there previously. So we could make a lifetime anthropology or has enormous impact on and planet. Now, there's a little bit of debate, which is humans advantage to industrial, and so a geologic period. We consider life on Earth. We consider one of the the dinosaurs, 6 human grasslands, introduction of etc. So this population with the human population, we're actually renaming history with a period named after ourselves. Now, what to do? Well, might be a temptation to this population growth. One could help increase birth rates and say I would just countries like China, there actually was, I'm sorry, the video, but it would be easier for that. But it is easy for people throughout the world to point to developments like the United States and say that there are people that are told the people there are, but also how much of the natural resources they use. Because even though the United States is 5% of the nation, it's 2% of the Earth's energy. It produces a quarter of the world's trash, and so the developed nations, their footprint on the damage done to the planet is far greater per capita than those throughout the rest of the world. And so rather than focusing on this part of the world, people, part of the world, because birth rates are higher, or part of the world is using more resources, the reality is it's all of our problem. We're all computing. We don't need to. One very positive result is that consider the fertility rate. So in 1950, the fertility rate in children per woman throughout the world was about 5. All right. So the average family / woman in the world had 5 children in 1950. That was the average. There were some areas where it was higher than that, some areas where it was lower, but that was the world average. And now notice that as time goes on, there will be fewer and fewer areas which are red and dark red, indicating high numbers of children per family, like 6 or 7 or even 8, and then larger percentage of the area which are now more blue, where there's 1, 1.5, 2, 2.5 children per couple, children per woman. So this is very promising, because if we were talking about a species other than humans, well, part of the answer would simply be, well, at some point, disease will start to wipe out this species, or starvation will start to wipe out this species. But obviously, we're talking about people here. We do not want the things which control human population growth to be the same as what would control the population of beetles or mice or whatever. All right, and you'd think that with our great intelligence, we could think of another way. And certainly there has been a very remarkable trend to decrease overall family size. Now, one of the things that has gone hand in hand with this is a decrease in child mortality. So as far as I understand, no area has significantly decreased its fertility unless child mortality has gone down first. And so saving more children actually then reduces population growth, because prior, in some parts of the world, family planning had included, the rather morbid reality that if you tend to lose this number of children, don't make it to the age of 10, then to reach your desired family size, you would then have more children, than that number to and just take into account that some would die. Now, if you were to look at the last year where the global estimates that I was using from the UN were available, in the year 2010, the world fertility was 2.5. All right, so here, so the average woman is having fewer than 3 children throughout the family, throughout the world. And compare that to just, only a few decades prior, where that number had been double. It was 5. So average fertility has dropped by half in a very short amount of time. Now, we're not going to see, population growth rates, there'll be a lag just because there were so many children born in the 1970s, the 1980s, the 1990s. They are just hitting their reproductive years, even though their overall family size will be less than what it once was. There's this huge cohort of people entering reproductive years. So it's not as if, the population growth rate is going to break at a halt. But 2.2 is considered replacement fertility. If everyone in the world, every family, every woman had 2.2 children, then the population would at some point stabilize, level off, and then maintain that and not increase anymore. So if, this leveled off and say the world's population was 8 billion people, it would hold at 8 billion people for thousands of years, potentially indefinitely, because the number of new people being born would be equal to the number who were dying. And so this is a significant event in this global increase, but then it has to be, all right, because our current rate of growth is simply unsustainable. And so I guess I'd like to end with 2 points. The first is, this is serious. It's serious for we people, all right, because if you were of the mind, well, in the next 40 years, we can't add the population of another China, another India, and 3 more United States. Well, if we're adding 1 billion people every 13 years or so, then we'll have to, because that's the number which will be added to the planet's population. This will have devastating impacts on food availability, on the amount of pollutants released into the environment, on the extinction of species which are losing habitat space. We already think it's the tied for the second worst extinction in the last 500 million years. If we add 3 billion more people, it will be far worse. And so one can't underestimate the severity of this problem. This is one of the greatest threats facing our species, is our success. All right, the planet is finite, and our ability to grow infinitely, that has to be curbed. The flip side is there are already signs that humans are adapting to this. World fertility is half what it was in 1950. All right, that's not that long a time to make such a serious change. And the human brain is, without exaggeration, the most complex structure in the known universe. So if we have the intelligence to mine fossil fuels and to create cities and to transform the face of the earth to the extent that an age of geology should be named after us, one would think that this same great brain could then be able to think of solutions, so the checks on our population would not be the starvation, the war, the disease, which would affect other species. So this has been an overview of perhaps the most serious environmental issue going forward.